So yeah, good afternoon. We're from Group 2. Me myself is going to do the video in a moment. And we are going to present about the South Island underwater data center. To recap, what is a data center? It's basically a storage of data and management, backup, and recovery, and other things related to data. It's also like mainly the place where the data is stored. Why are we proposing this? Because want to protect continuous and place it as far as possible from the code, and also using the environmental as a cooling device, it will technically use less energy. And we're going to discuss about the power generation, safety, and communication. First, for the power generation, for tidal power plants, one example is the Siwa tidal power plant. It generates annually 552,700 gigawatt hour, which equals to a daily generation of 254 megawatts. And comparing the power generation with the standard consumption, the Google data center consumption have a total consumption of 15,439 gigawatt hour in 2002 out of the 16 centers. So it averages around 965 gigawatt hours per data center. And with this comparison, the tidal power generation can definitely sustain the power needed for the data center, but the full autonomy is still not yet clear. Economically wise, we can calculate using the PUE, or power usage effectiveness, which is the total facility energy divided by the IT equipment energy, or is equal to 1 added by the non-IT facility energy divided by the IT equipment energy. The closer it is to 1, the better it is, since then the energy is only concentrated to the IT equipment. UE is also a ratio that describes how efficient a computer data center uses an energy, specifically how much energy is used by the computing equipment, comparing to other things. And for project mapping, which is done by Microsoft, once the underwater data is up and running, we use a manifold that uses some kind of like valve to adjust the cooling of the data center. And with the manifold, the PUE of 1.07 is achieved. This is you can compare it with the Microsoft, the latest generation. Data center have the PUE of 1.125, and the PUE without the manifold is estimated to be 1.3, although it is not that. And seeing this, we can see that even without the manifold, the PUE is quite low. And there's no external heat exchanger. Microsoft uses their seawater, raw seawater heat exchanger, and then back out. So it is the same technique used in ships and submarines. And the speed on which the water flows, it also discourage the barnacle growth. So there won't be any blockage in the uh, water system. And the cooling system could also cope with high power density, such as the ones required by the GPU, and use and servers used for heavy performance computing and AI workloads. And then lastly, this is more like how the power consumption of a data center is. It's mostly on the server and the cooling and power. Once we change the cooling system into using the raw seawater, this huge 43% power can be diminished and thus use less power consumption for the data center. Next, we will talk about the safety. For the structure itself, it needs to be cylindrical since it's the strongest shape against compression. With the high water pressure, like because we put it inside under the sea on the ocean floor, it needs to withstand the compression of the seawater. And with cylindrical shape, it doesn't have any edges, meaning it doesn't have any weak points. Also, with using as little joints or like welding points as possible, it will have a stronger structure since the joints are the source of leakage, and also it is the weak point of the container. Against the pirates, for Microsoft's Project Matic, it's put in the depth of 170 feet, which is equal to around 36 meters under the ocean surface. For a pirate to dive, it is by the association, diving international association. It's considered a very deep dive. So like the maximum for the deep dive is 30 meters. So it requires a special gear. And there is also the hazard of nitrogen narcosis when diving below 30 meters. And so for pirates to get the data, they need to go for the cables. But then, as we know, it's a very big dive, so it's hard for them to get to the cables. So they need to hack the server. They want to get the information. And by hacking the server, as we all know, data centers have multiple layers of safety, and it is very hard to get into the data in the data center. Next, or if the pirates want to take it physically, for the Matic project, it's placed in Orkney Islands where which have high tidal current. And this also equally means that it is a dangerous water. So you cannot even Microsoft themselves, they cannot go anytime to place and take the Matic project, like their data center. They need to take it. They need to go when the sea is very calm, which is atypical, which are like not common, and they need robots that are clearly or like very beautifully choreographed to perfectly like hook the winch to the data center and like taking it, and it's also very time consuming. It takes the Microsoft 1 day just to put the data center down, and also 1 day to take it out. So it is highly unlikely for a pirate to just go and take it physically. Next, we will talk about the communication. There are two technologies available in this day and age. There's the cable connection and there's the wireless internet connection. As of today, 95% of all communications, both phone, email, and etc., is done through submarine communication cables or like subsea communication cables. And this cable also ensure about 99% of all continental information can flow and is reliable and used all over the world. The satellite connection can also be used since there's also now 5G connection and the 6G I heard is also developing. And it may be an interesting choice. But then for the data center, we need to make sure that data is kept quite far away from the coast. But also it needs to be useful or like it needs to have a good speed since the data will be taken in and out. So then we can compare the connection from the cable and also the wireless internet. As for the speeds, the cable connection wins by a huge margin. It can operate on 9.5 terabit per second, comparing to wireless internet connection of just 1 gigabit per second. And the cost of cable connection is $27,000 per kilometer, whereas the wireless internet is $4,000 per 64 gigabyte RAM capacity server. And what they need is more or less they both need cable. For the wireless internet connection, it's for the cable from the floating antenna to the server itself. And for the cable connection, it's from the server to the LAN. And also signal repeater and amplifier is needed for the cable connection since the signal can drop in the middle of transferring. But there is of damage for cable connection, the ship anchor can damage it. Fishing trawler, earthquake, turbulent currents, and animal bites is the risk of damage. And for wireless internet, the storm can involve bites and ship collision. Transmission stability is at risk for cables only when it is broken. But then for wireless internet, for bad weather, there is transmission stability risk there. And it also why it is very dependent on the weather for the transmission. And to maintain the connection, for cable connection, they can just bring the cable up to the surface and to maintain. But then for the wireless internet connection, it's very dependent on the issue of the problem. And like they might even need to take the data center up to the surface. For the energy consumption, the cable connection have a lower energy consumption, whereas the wireless internet have a very high energy consumption. So this is one picture of the fiber optics that is used. Using the speed of the server for the wireless internet connection makes it really complicated to realize because it will need a huge quantity of electric power. And also, in order to make it usable, the electric power generator has to produce enough electricity to cover both the consumption of both the server and the computers. using the wireless device is too uncertain since it is very affected by the weather and it's not reliable enough to fully count on. And then the data transmission is also not enough for commercial use. And the network was saturated fast enough and no longer usable. And so we decided on using the wired connection. And the wired connection itself, using fiber optics or optical fiber, with a gathering of 12 pairs of optical fiber, it can go to speed of up to 26 terabit per second. And currently, the average signal speed is around 9.5 as in the table. And this speed can also be higher in the future with more pair of optical fibers. With the cost of around 27,000, it's very high speed and resistant underwater cable. And the maintenance of the cable needs usually only about 16 hours to totally repair the cable, which is the which is with half which is most commonly damaged by the ship, which commonly broken by the ships, the boats, especially the fishing boats, by their anchor. And to conclude, so we concluded that we will use a cable connection and that the tidal power generation is able to generate enough electricity comparing to the power consumption of an average data center. And the traditional data center uses much power to operate and sustain the center itself. The average PUE of a large data center was around 1.57, but then the underwater data center have a PUE of 1.07, which is much more effective. Lastly, the full autonomy looks possible for underwater data center, but still it needs more technological development. Thank you. That's it from me.
All right. Question from other things.
Okay, how to calculate maintenance cost compare with lower data center and underwater data center and two types of underwater center? Or no, yeah, we haven't calculated maintenance cost for that. So, please share your opinion for maintenance itself. Since those underwater data center is not engineers will not go back and forth to do it, and then it requires maintenance of for like 2 years, if I'm not mistaken. Whereas for like the data centers, it needs regular maintenance. Because our engineers go in back and forth and there might be fault in the what they do. And also with the data centers on land, there's also risk of the dust also and everything else. So the maintenance cost, even if like it's expensive to do like one-time maintenance cost over the long time, I think the cost will equalize, at least equalize each other.
Okay. Any other? Yeah, sorry. No, okay.
I like the part that you guys shows the numerical things that in the economy part. but also the presentation files, the material is graded. So there's a lots of parts you explain in your speaking, but some of your parts in the speaking does not include it in the presentation material. So maybe you need to include the little more details about your speaking, and then yeah, that will be help to your grade.
Great. Good point is you introduce a new index for PUE. And also safe consideration, secret consideration is good one. Question is what is a use of manifold?
Yeah.
Is it for cooling or is it for some?
So the manifold is mainly for cooling.
Cooling?
Yeah. So the manifold is basically the cooling system and like experimenting with different bulbs. The Microsoft team, we can find the best cooling strategy, and with it, we found that the PUE can be like 1.07.
Right. And nothing, the 11, page 11. Right. At the image, above the cylinder, there is a structure. It's called a superstructure. What is it for? That structure is used for what? You know?
I'm quite not sure about what this structure is for, but most likely it's the cooling system.
Cooling system.
Yeah. But for like this is the one done by China, like a Chinese team who this project also try to implement the project also. So I did not really research on that team's research.
If it is used for cooling, then it can be a heat exchanger. Anyway, and then yeah, competition. Is it related with what is the objective of this project?
It was to put data center underwater, and yeah, so and also it needs to be like self-powered, so the energy generation will not be dependent on the energy generation from that.
Right. So then you need to show us the competition, something like conventional land-based data center or other project if there are underwater, if there is say yours or nothing. You may provide your own idea at first, then you need to compare with nothing project and yours, and also conventional land-based system. So that we can see that yours are better than the others. So final one is you may use more image or video for your presentation. That can help us to understand the later. All right, thank you very much.
Oh, one more question. Is the you guys present the schedule of the presentation term project and the proposal, right? So term project schedule, whole schedule. So what do you think about the achievement? Do you achieve the proper rate when you present in the proposal?
I think yeah, we do achieve the proper rate. Maybe on some parts it's like a bit ahead of schedule, but yeah, it's on track with the schedule.
Okay, thank you.
All right. We want to 3.